we are going to continue our study of factoring techniques, and in particular we are going to focus on something called special forms in factoring. The first special form is called difference in square. So what this means is, if you see something that is the difference of the square of two things, it can be written as the product of the sum times the difference. Let's check that this works. If you FOIL out, the x times x gives you an x squared. The x times y gives you a positive xy. And then the negative y times x gives you a negative xy, and a y times y gives you a negative y squared, wherein these cancel out, and so these are the same. Now when you apply this particular special form, what happens is you'll have something squared minus some other thing squared, and that comes out to a product of the difference and the sum. Now let's look at it in terms of area analogy. So what we are doing is we are taking a square of side x, and from there we are subtracting a smaller square, say of side y. So if I remove this yellow part, right, what I'm left with is this. So x squared minus y squared would be a shape that looks like that, right? Okay, now let's see, what are these lengths? That is x, this length is y, and this length is y, which means that if I were to break this into two smaller, say I don't want this L shape, I still want rectangles, then this big length is x and this small length is y, which means that this length here is x minus y. So this is actually one long rectangle with side x and x minus y, and it is this other rectangle which is y. So this length is y, and what is this length? So if you look at this length is x minus y, right? So you have this, which is x minus y by y, and the areas add up. So the total area is going to be x times x minus y plus y times x minus y, which when you take the GCD, it's going to give me x minus y times x plus y. So let's look at some examples. Now in this one, it will help you to know the squares of some of the first few numbers, right? So like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. So maybe you should keep in mind that if you see one of these numbers, then it should be a callback to, it might be a factoring by difference of squares, right? So the first 10 numbers, you should be familiar that these numbers are squares. So with that in mind, this is x squared minus 9 squared, so this becomes x minus 9 times x plus 9. Similarly here, notice that 81 is actually 9 squared, right? So if I rewrite this, this is 9 squared x to the 4 minus 4 squared. So this is, right now it's not in the form of something squared minus some other thing squared. But 9 squared x to the 4 can be written as 9x squared squared minus 4 squared. Now to make sure this is understood, because what is 9x squared squared is actually 9x squared multiplied by 9x squared. And then 9 times 9 is 81, and x squared times x squared is x to the 4. So you do get back 81 x to the 4. Now, the difference of square is being applied to this yellow term and this yellow term. So you get whatever is inside, which is 9x squared minus 4 times 9x squared plus 4. Now this is where a slight bit of complication comes in that this is a subtraction, right? And 9 is also square of 3, and 4 is square of 2. So this can further be written as 3x squared minus 2 squared. So this term itself can be factored further into 3x minus 2 and 3x plus 2, and then you also have the 9x squared plus 4. So in this case, you apply it twice, right? So the goal is to keep applying it as long as it can be applied, because you want to get to the most simple form. And the most simple form here happens to be when you apply it to 9x squared minus 4 to get these, and then this is not a difference, so you cannot apply in that case. Same way here, 4 and 16 from the list is 2 squared and 4 squared respectively. So this would come out to 2a minus 4b, 2a plus 4b. Here too, you might take an alternate route and first do a GCD. There's a 4 and then a squared minus 4b squared, and then apply this to a squared minus 2b squared, which becomes a minus 2b and a plus 2b. So using that GCD method might be helpful. Let me change this problem a slight bit, make that plus. So we're going to do the GCD here again just to get it into a familiar form, or I'm going to rearrange it first. So one way is I rearrange as 1 minus 16x squared, and I take note that 1 squared is 1. So I can always write this as 1 squared minus 4x squared, and then it becomes 1 minus 4x and 1 plus 4x. Alternately, I can take the GCD to be negative 1, but this is more complicated, and I get a negative 1 4x squared minus 1 squared. Remember, a very common trick, because 1 squared is 1, oftentimes we will replace 1 by 1 squared when it comes to factoring. And then this is 4x minus 1 and 4x plus 1. Okay, so these are the same thing, because if you distribute this negative 1, it becomes 1 minus 4x. So that's it for this video. We have a few more special form factoring that we will go over, and also do a bunch of examples. Thank you.